Lesson 7-6, Connect Proportional Relationships and Slope. In this lesson, you are going to learn how to take what we know as the unit rates and connect this to what we call the slope of a line. The process that you've been using from previous lessons and topics on proportionality is going to be very useful to you in this lesson. If you need a review, go back and look at Lesson 7-5, where we talked specifically about comparing different types of proportional relationships. Now take a look at your solve and discuss it. In the fall, Rashida earns money as a soccer referee for her town's under-10 soccer league. So far, she has worked 5 games and has been paid $98.50. She will work a total of 14 games this fall. How can Rashida determine how much she will earn refereeing soccer games this fall? Well, the first thing that we need to do is we need to find out how much her daily or her rate is per game. In this case, $98.50 is what she's earned so far, and that's for 5 games. So first, figure out how much does Rashida earn for 1 game. Hopefully you found that she earns $19.70 per game. Now we need to know about what her pay should be for 14 games this season. If she gets paid the same amount of money per game, then we can take that pay for 1 game and multiply by 14 to determine how much she will get paid for all 14 games in the season. By using proportional relationships, we can determine that Rashida should earn $275.80 for 14 games this fall season. In example 1, we aim to understand what slope is. And what you'll find is that it's a very familiar concept, just with a new name. Maya and her father are building a treehouse. The roof will have a 9 to 12 pitch. That is, for every 12 inches of horizontal distance, the roof rises 9 inches. How can Maya determine the height of the roof at its peak? Step 1 is to make a table of values that show that 9 to 12 pitch, or the ratio of 9 inches of height for every 12 inches of horizontal distance. Remember that 12 inches is equivalent to 1 foot. So as we look at the diagram here, we notice that the distance to the center of that roof is 6 feet. Okay, so that 9 to 12 pitch here equates to a 3/4 of a foot to 1 foot ratio in that constant of proportionality. So your constant of proportionality each time is 3/4. Step 2 tells us to graph the ordered pairs from the table and draw a line to connect them. The line shows the steepness of the roof. The steepness is also called the slope. Okay. The slope of a line is a ratio that describes for us the rise, or that vertical distance, as it is compared to the horizontal distance. So the rise is the change in the vertical distance, whereas the run is the change in the horizontal distance. So it's always how high does it move up or down compared to how far does it move from left to right. Maya can use the graph to find that the roof is 54 inches in height at its peak. So remember, because the initial distance between the edge of the roof line here and the center of the roof line is 6 feet, then you're going to have to move over a total of 6 times for that vertical distance and 6 times for the horizontal distance. That's where you get these 54 inches in height for 72 inches in horizontal movement, because your 6 feet is the same as 72 inches. Okay? From where we are on the graph, you might also notice that every length on your graph counts by 12s. So these are all increments of 12, which means this last mark over here would be where 72 inches is. And then you would need to look up here to see where it crosses that y-axis, and halfway between the 48 and the 60 inches is that 54-inch mark. Remember that the slope of that line, or the slope of the roof line in this case, is that vertical distance divided by the horizontal distance. That's the same thing that we did when we found a unit rate. Now let's look at the try it at the bottom of your page. Jack graphs how far he plans to bike over a 3-day charity ride. Find the slope of the line. Remember that the slope is the rise, which is the distance that we move up or down on the y-axis, divided by the run, which is how far we move from left to right on the x-axis. So it is still that ratio of y over x. In this case, notice on the graph that they are finding the distance between the x values and the y values. Well, from the point 260 to the point 390, we've moved over a total of 1 on the x-axis. We moved from 2 to 3. On the y-axis, we went from 60 to 90, so we moved up 30. The 90, remember, would be right there. So we moved 30 on the y-axis, and we only moved 1 on the x-axis, so the slope of the line is 30. How does this unit rate and the constant of proportionality relate to the slope of a line? In this case, they all represent the same thing. And each is described as the amount compared to 1. Let's move on to example 2. In this example, we're going to find the slope using 2 points from the graph. The graph represents the depth of a diving submarine over time. At what speed is the submarine descending? Remember that the word descending means that the submarine is going down. In order to find the slope of the line, we need to look at how the submarine's depth is changing over the course of time. So we're going to choose 2 points from that line that describes that submarine's change in depth, and we're going to use those 2 points on the line to describe the slope or the steepness of that dive. Okay, the slope can be found by using 2 values. One is called the rise, and the other value is called the run. Okay? The rise is what we use to describe the change in the depth. So that is always going to be the difference of your y values or your y coordinates. The run is what we use to describe the change over the course of time in this problem, and that would be the difference in your x coordinates. So as you look at these 2 points on the graph, so the first point here is the point, it looks like the point 5, negative 400. And the second point is the point, let's say that is 10, negative 800. We are going to use those values as your x's and y's. Now, it doesn't matter which point you call the first point and which point you call the second point. What you're aiming to do here is to find the difference between the 2 y values, which in this case are negative 400 and negative 800. And then you're going to find the difference in the 2 x values, which in this case are 5 and 10. So when you find those differences, you're subtracting them. So how much deeper did that submarine go when it left the depth of negative 400? Oops, that's the wrong color. Let's try this. And then gets to a depth of negative 800. Well, the change in depth is that it went down an additional 400 feet. Then we look at the change in the time. In this case, at negative 400 feet, it had been 5 minutes. And at negative 800 feet, it had been 10 minutes. So the difference is 10 take away 5, or a difference of 5 minutes. Negative 400 divided by 5 is negative 80. So the slope of that line is a negative value. It indicates that it is descending or still going down at a rate of 80 feet per minute. So that slope still tells us about the unit rate. Example 3. In this example, we're going to learn to interpret the slope. The graph shows the distance a car travels over time. Find the slope of the line. What does it mean in the problem situation? So in other words, what does the slope tell us about the distance traveled for this car? Remember that slope can be found by finding the difference in the y values and finding the difference in the x values. The rise, remember, tells us how far we move up or down, and the run tells us how far we move side to side. So in this graph, in order to find the slope of the line, we first have to identify the two ordered pairs. In this case, the ordered pairs are 2, 110, and 4, 220. Since the first ordered pair, we would label x1 and y1, and the second ordered pair we label x2 and y2, we're going to use those values as we do our subtraction. So when we find our slope, we are going to subtract y2 minus y1, so that's why you get 220, take away 110, and x2 minus x1, which is why you have 4, take away 2. And when you do that, of course they don't show you this step, the difference is 110 divided by 2, which is 55. So then the question is, well, what does that mean? If the slope of the line is 55, what does that tell us? And what it tells us is, it tells us that unit rate, that the car travels 55 miles per hour. Now I'd like for you to complete the try it. Pause the video while you do that, and then come back and check your answer and explanation that goes with that. Now let's check your work. The two ordered pairs from the graph are 25-35 and 50-70. By labeling the first ordered pair as x1, y1 and the second ordered pair as x2, y2, I can subtract them to find out that the top number, or the difference in the y values, is 35 and the difference in the x values is 25. And I can simplify that into the fraction 7/5. Now, a lot of times we would say, go ahead and make that from an improper fraction to a mixed number. The problem here is that that doesn't allow us to make that same interpretation. So when we say the slope is an improper fraction, what it does is it allows us to give the definition of that slope based on the labels that you see on the graph. So when I say the slope is 7/5, what that means is the 7 still represents the y number, or the drops of red food coloring. The 5 represents the number of drops of blue food coloring that you see on the x-axis. So Taylor uses 7 drops of red for every 5 drops of blue. That's the ratio he uses in order to make purple food coloring. Now let's go on and try some other problems together.